Good morning, everyone. Welcome all participants for first session of 4 day of STTP on Environment Engineering for Global Sustainability, organized by Saraswati Institute of Technology, Kharghar. Participants, it's my great pleasure to introduce our honorable speaker, Mr. Vijay Kulkarni sir. Mr. Vijay Kulkarni sir has a vast experience of more than 40 plus years in different spheres of civil engineering. He worked as a design engineer at the Koina Hydroelectric Project. He was involved in the design of some of the major bridges in western Maharashtra like Bhima, Krishna and Saina River. He developed fly ash based grouts and bricks, fast track industrial flows, etc. He contributed immensely to the R&D project on high performance concrete which was carried out jointly by ACC Limited and Atomic Energy Regulatory Board. He conducted the work of the quality audit of the Mumbai Pune Expressway, which is the first concrete expressway constructed in India. He did a health assessment of various structures with NDT. He worked as an editor of the Indian Concrete Journal and was instrumental in the publication of more than 60 special issues of the journal on varied topics in civil engineering. Also, involved in the publication of several technical books. Presently, he is associate with the Ready Mix Concrete Manufacturers Association as its principal consultant. Also, a member of the technical committee and the sustainability committee of the European Ready Mix Concrete Organization. He possesses expertise in the design and production of HSC, HOC, self compacting concrete, polymer modified concrete, lightweight concrete, etc. As a member of the Bureau of Indian Standard Committee on Cement and Concrete, he contributed his knowledge to the revision of various Indian standards on cement and concrete. He was the convener of the Second Asian Conference on HUSI in Concrete, organized by the Indian Concrete Institute and the Asian Concrete Federation in Mumbai 2005. He was the vice president of the Indian chapter of ACI from 2004 to 2005, the president of the Indian Concrete Institute from 2009 to 11. He is the chairman of the ICI Technical Committee on Durability, member of the Concrete Committee CED 2.2 2.1 of the Bureau of Indian Standard. He awarded as an outstanding concrete technologist in 2016 from ICI. Also, Vishweswariya Construction Excellence Award as a eminent editor. He got a gold medal from the IRC for the best paper on the Mumbai Pune Expressway. Also awarded M. Shivaram Medal of the Best Study Paper at all India levels in Deep in Journalism. He has presented around more than 60 technical papers and lectures delivered in various national and international seminars and conferences. Currently, Sir started a low carbon construct forum not for a profit company but for creating awareness amongst the construction industry profession in India on the dangers of climate changes and carbon reduction. So, participants, due to the time limit, here I present very short information about our today's speaker, Mr. Vijay Kulkarni sir. Now, I would like to hand over this session to our speaker, Mr. Vijay sir. Sir, please.
Thank you, madam. Thank you very much, and hearty welcome to all the participants for today's lecture. I think first of all, you would be wondering as to why I have given this title of, Net Zero Carbon 2070, 2070. Most of the people will feel that it is too long, 2070. Why we should worry right from now? But once you go through the presentation, maybe some of you will understand the gravity of the situation, the dangers posed by the climate change, and unless we act right from now, we will not be able to achieve. whatever we wanted by 2070. Now, this 2070 is also a commitment made by our Modi government. Okay, he has made this solemn pledge at an international forum, and we have to respect that. But the many other countries, they have decided to achieve net zero by 2050 only. Well, I'll come to that later. So, most of my work, Madam has already told that I had worked in variety of field and mainly in cement and concrete and design of bridges and buildings. But lately, I was attracted towards this climate change and understanding the urgency of the situation and the dangers that the humanity has to, will be facing because of this. I had been studying this topic for last 2 years very closely, and based on some of these, literature which is available, I have made published around 5 papers in the last 3 years, and they have already been published, and maybe it could be made available to you, or it would be available because they are already available on the net, internet, and by the various publications. Uh, so, with this, I think I will start. This is the brief outline. Maybe I told the head of the department that maybe there is quite possible that whatever I have been talking today must have been spoken already by some other speakers. But since I was not aware what they have been presenting, I will have to, you will have to bear with me for this repetition which might be there. So, first of all, I think coming to this very interesting or very famous diagram, which came out in 2014 by the Intergovernmental Panel on Climate Change. Now, this Intergovernmental Panel on Climate Change is a world body set up by the United Nations and consists of mostly the environmental scientists. So they have been studying and they have been, publishing this various report. I think they have published till today 6 reports and also sub reports. A huge data is already available, and one can study that. So what they have been saying is that there has been a unprecedented rise in the greenhouse gas emission. Now, these three gases we know, carbon dioxide, then methane, that is CH4, and nitrous oxide, N2O. These are called as the greenhouse gases. And the problem with these gases is that they they the ones they are generated, they remain into the atmosphere, and they tend to heat up the earth's surface. And the second problem is that they never go, they have been accumulating over years. And as you can see here, from 1850 onwards, you can see here that sorry, 1850 onwards, you can see here how the curve is going like this. The CO2, it is just crossing boundaries. And then this is, of course, the methane and nitrous oxide. But one of the gases which has gone into the atmosphere because of the rise in population on one hand and industrialization that has happened during the 18th and the 19th century, all these gases have remained, got accumulated into the atmosphere, and they are now causing very serious problem. For example, they say that the CO2 emission has reached the highest level, which was not there in 8 lakh years. So you can see here it has almost started from nil to this level, and now it has become quite a dangerous thing. And also, because of this greenhouse gas emission, there has been a rise in the temperature, and it has been, as you can see, that we are experiencing warmest period now, which were not there in 1400 years. So these statistics is very revealing. Now, what there has been another report by this scientist, which has come in 2018 by the International Panel on Climate Change, and now they are, projecting the data. And as you can see here, already the temperature has gone from 1960, because they are not saying from 1800, but 1960 this has gone, and almost the earth temperature, which was less than zero point 0.5 increase, you can see here. Now we have reached a stage where the temperature, average temperature, has gone to 1.1 degrees centigrade. And now they are projecting as to what will happen if the temperature goes to 1.5 or 2 degrees centigrade. That is, the average temperature of the earth goes beyond this limit. And what they are saying is that the tipping point is 1.5 degree. That we should not allow the average temperature of the earth to go beyond 1.5 degrees centigrade. And this scenarios, various scenarios, has been projected as to what will happen if we are not able to do this. Now, as everybody knows, that we have been facing devastating changes because of this problem. And these are the floods, the cyclones, the drought, and the wildfires. Now, what has also been seen is that the gravity, or the intensity of these disasters has been very high. And this can be seen even in our own country. As you can see here, this is the flood in Uttarakhand last year, which has created havoc, and many people have died. We also had the floods in Kerala, which I think is the next slide. Here you can see the Kerala example. So Uttarakhand and Kerala, they are facing almost the same situation. Another is the example of Rajasthan, and this is an area which is supposed to be a drought-prone area, and you can see how much is the serious situation in Jaipur. It has risen last year. These are all last year's data which I am showing to you, that we have been facing this unprecedented change in the climate. We are also facing some of the serious cyclones, and this is one example of cyclone Varda in Tamil Nadu. And the east coast of India is prone to cyclones, but now the west coast also is now becoming prone to cyclones. On the western coast, Maharashtra has witnessed three cyclones last 2 years, I think, Tautke and then Nature and many others. And we will be now facing more and more such problems. So all these are attributed to the climate change. This is another problem that we have faced very recently, and this entire area is heat wave area. In April, this is the picture released by our own meteorological department. which shows that this entire area of faced extreme temperature, which was highest in 122 years. And then we have also faced something like maximum temperature going to 47, and sometimes we have reached even some areas even 50-degree temperature. So this is all happening again, and this is the latest example of the heat wave. So we are going to face this again and again. And now, what is the effect of this? I think there are many effects, but one effect which has been published recently in Times of India, I think Times is okay, which the article showing that it affects the food security. Food security. Now, the simple thing is that many of us must be having the rural background. So we know that the flowering and the uh, the crop comes because of the pollination. For pollination, small creatures are responsible. Now, if the temperature goes up, now we are seeing the extinction of many of these creatures, and if it continues, already the data shows that the food production has been showing reducing trend. So if we continue the same way, we may face, the world may face very serious situation. This is one of the effect of the climate change. Now, this is the UN data on disasters between last 20 years, which shows that the numbers has increased, floods, storm, earthquake, extreme temperature, landslides, etc. There's also the UN data also shows that how much money is lost, and the figure is mind-boggling. Something like $3 trillion, I think, which means 3,000 billion dollar has been the damage. And if you see India, I think India happens to be the third largest country which has experienced a number of disasters compared to many other countries. Now, there has been efforts in mitigation, and as you may be aware, that there is conference of parties which has been happening since right from 1995. Some 25 such conferences have happened throughout the world, but one which has happened in Paris, that is COP, Conference of Parties 21, where all the world leaders have come and they have agreed that yes, now they have agreed, at least there is a broader agreement that there is a problem of climate change, and they have agreed that they will try to keep the temperature of the earth, average temperature of the earth, below 2 degrees centigrade. This was agreed in 2015, and they will also make efforts to reduce it to 1.5, keep it to 1.5 degree temperature. Now, unfortunately, the US withdraws from this Paris agreement, but again, fortunately for the world, it has again joined after the change in government in the United States. Now, as far as the scientist community, scientists or those who believe in science, there are large number. And these 11,000 scientists have come together and they have issued a declaration. Now, what that declaration says very clearly that the climate change has arrived and is accelerating faster than most scientists expected. So, even the scientist has not expected that this will accelerate, and we are seeing the effects that this has accelerated to such an extent. And it is more severe than anticipated. So this also we are seeing and threatening the natural ecosystem and fate of the humanity. So finally, we are now at such a juncture, and we have neglected the warning given by the nature, Mother Nature, that such a situation has arrived. But yet, I think there are people who say that we can still work on, and the concept of net zero has emerged. Now, what is this net zero? Net zero is nothing but a pledge or a action by which we reduce the carbon emission and other greenhouse gases into the atmosphere. There are ways and means of doing that, and why, how we are involved as engineers. I will come to that later. So this is, I think, one of the latest thing which has come in 2022, and again there is warning happening from the international panel on climate change that the situation is beyond our control, going beyond. What is the Indian scenario tells us that one thing is there that we are more vulnerable than others. And this is the data published by the no less than State Bank of India, because they are ultimately counting it in terms of rupees and Nawa Paisa. So they say that we have lost something like, the casualties is 83,000 lives have been lost and 100 crore person were affected. So most of the population has been affected. And there is a GDP loss of almost 6% GDP loss, so which is very serious loss. And they give the reason why we are more vulnerable because we have a India has a high population density which is increasing. We have a fragile ecosystem which we have neglected for years together. We have low resilience. You must understand what is resilience, and that is what we are now as engineers. It is our duty to improve or enhance the resilience and protect our community, our society against the climate change. And of course, our economy is not as strong as the advanced world. Now, one of the scientists, again Indian scientists, they have attempted to create a vulnerability map of India, and this has been done very recently by the the Council for Energy, Environment, and Water in 2021. And uh, what does it shows? It shows that the entire red area is under danger. And what they say is that almost 80% of the India's population lives in districts that are highly vulnerable to extreme hydromet disasters. And we have been witnessing that whether it is Uttarakhand, whether it is Rajasthan, whether it is coastal Andhra Pradesh, Tamil Nadu, or whether it is coastal area of Kerala or Karnataka or Maharashtra. We have been witnessing that, and of course, the Himalayan also is becoming more and more fragile climate. India also happens to be the fourth largest CO2 emitting country in the world today. This is the data published by your mm, International Energy Agency, which is a very well-known agency. So you can see here that India is growing its CO2 emission, whereas the United States and European Union are reducing their emission, but China is again going up and up. So we will further go we will further increase our CO2 emission because uh, we have to develop. We are a developing country. So as the development happens, the carbon emission is directly proportional to the industrialization and the increase in the population. So we are going to emit. So, but of course, there are people who are saying that, and we I am presenting this data from five big studies which has been done in India by a well-known organization like Terry, McKenzie, and many other, which shows that that the average per capita emission is still low because of our population is large, and that is why they say that our average emission will be much lower or equal to the world average. But I don't buy this argument because ultimately, but this is a fact. This is a fact, and this becomes very clear that already the developed countries have occupied the carbon space in the environment. Now, compared to their population, the carbon space occupied is, improportionately very high. Whereas India, we are just having 17% population, but yet only 3% carbon space we are occupying. But can we now say we have reached such a stage today? And there is also one argument which goes that the global carbon inequality. They say that the champagne glass is very clear that the richest country are responsible, which occupy only 10%, they are responsible for almost 50% of the emission, whereas the poor country are responsible for less emission. So this fight is going on, and this is one of the reasons. I think if you see little bit of international diplomacy, you will understand that the developing countries have been arguing that we are not responsible, like India is not responsible for this scenario today. It is mainly happened because of the unprecedented use of natural resources by the developed countries of Europe and America and now China. So it is, they are arguing that it is the duty of these countries to give money to the developing country, and they are now demanding something like a very huge amount of maybe around $5 trillion from these countries, and this is negotiations happening at the international level. So just as a side change, I'm trying to give you this information. But the point is that, and our government is very clear on that, that the nature is not going to wait. Nature doesn't distinguish between developed countries and the developing countries. It is going to hit us. Now, if it is going to hit us, we have to be prepared for that. So our government has taken a very wise stand saying that we agree, and this has been agreed by Prime Minister Modi in 2015 during the Paris Convention that although it is not a binding on India, India agreed to reduce the greenhouse gas emission and also improve the increase the enhance the yes, the renewable energy. Coming to India, other activity, there is an CEO forum of big companies, which has also declared that they also respect us because they are one of the biggest companies in India, and they are also responsible for most of the emissions that's happening today. So there are Reliance, there is Tata Group, there is in the cement also there is ACC, Ambuja Cement, and already this list is now growing, and they have agreed that they will set up the greenhouse gas emission targets, and they have energy improvement goal, and uh, they have agreed to all these things which I have been showing on the screen, that they will do energy efficiency, material efficiency, renewable energy, and improve process technology, water efficiency, green mobility. Everything they have agreed, but they are not yet agreed to net zero. Of course, there are some few companies already that I remember, like Infosys, like many IT companies, even L&T has also committed, one of the biggest construction giant today in India, that they will become net zero by 2050, 2050. So they have made commitment, and they are now going ahead, taking plans, making plans and pursuing it. In fact, now the World Bank and many other financial institutions in the world, they are now, you know, giving money or giving loans to various countries and various companies based only on their performance in the field of, you know, environment, social, and how you behave in that area. And so nowadays, you will find that even the annual reports of these big companies, they have to include this information. Now, this is what I think has been agreed by our government in 2000. I think this is happened in Glasgow conference. So in 2020 only we have agreed, 21 I suppose, and this commitment is made by our own Prime Minister to the world in a recent conference. So we have to respect this, that huge amount of renewable energy will be produced in India, and we will slowly reduce the use of fossil fuel. Fossil fuel means all coal, petrol, petcoke, etc. We'll reduce it, and then we will also reduce our intensity, increasing the green cover, etc., etc. Now, there are some people who say that even if the world has agreed, and even if they have pledged to net zero, nothing this is going to happen, that we will not achieve, even if all the commitments are made here, we will still be achieving around 1.5 degree temperature in 2050, somehow or the other. But the question that is raised is, will the countries and the companies, will they agree to their commitment by 2050? So it is our own area. Now you will all the time must be wondering why I am unnecessarily troubling you on this area, which is actually not directly related to our civil engineering or environmental engineering area. The reason is simple. The reason is that the building and construction, they are responsible for huge amount of energy consumption and also the CO2 emissions. So if you see, this is a global picture, that our building and construction sector consumes something like 36% of the total energy generated in the world, and they are also responsible for 37, which means more than one third of the emission is happening because of the construction of building and other construction which is happening today. So the naturally, although efforts are made in the transport sector, that today we hear that this petrol is being now having ethanol content going up to 10%, and it will go to 20% also by 2025. This is the government of India has been doing this exercise very seriously. So slowly the petrol and diesel and many other energy requirement will be uh, taken care of. But yet, I think it is a very costly process. For example, generation of renewable energy, use of transportation of renewable energy, transportation. All these are very costly items. So, what the experts are telling that it is more effective and cost effective if the building and construction industry is able to reduce its emission from 37% today, going on reducing it further and further. Now, how should we reduce? The first thing is that we have to have energy efficiency in our sector, in building and construction sector, and we have to decarbonize the power supply, electrification through renewable energy, and also embodied. Now, this is where we come into picture, that embodied carbon. So there are two types of carbons. One is this, operational carbon and embodied. I will come to that, but before that, my topic is, what is the role of the engineering fraternity in this area? So the main thing is that some definitions, of course, that carbon dioxide equivalent. Now today we talk of CO2e, which encompasses all the greenhouse gas emissions, that is CO2, CH4, and N2O. And this is broadly referred as carbon. So when I say carbon emission, it means that I'm talking of carbon dioxide equivalent. So CO2e I'm talking, and what is said is 1 kg of carbon has a global warming potential of 1 kg CO2e. So this is simple to understand. So when we talk of whole life carbon, it is consisting of operational carbon and embodied carbon. So we have to understand both the thing, what is operational and what is embodied carbon. So this is before going to that, I'm just trying to tell you that besides the government, various government in the world, our fraternity, our engineering fraternity has come forward, and this is a very enlightening, encouraging development which has happened today. That the civil engineering and the structural engineering fraternity has come forward, and they are now saying that okay, we will do this. So this is what the Green Building Council, the World Council of Green Building, they have committed that by 2030 they will reduce the operational carbon almost drastically, and by 2050 they will become net zero. So this is what they are saying. It's all building. This is their commitment and World GBC. Now there are professional body like Architecture 2030. Now, this is a world organization. They have also come forward, and the body of architecture today are saying that, okay, we will help this situation. Henceforth, all our design and all our planning will be based on how we achieve net zero. There is structural engineering community. They are also come forward, and they are also saying almost the same thing. There is one interesting, I think this is very inspiring. This is the first thing that I came to my notice, that there is people from United Kingdom, that is London. Basically, people from London. They have all the some 100 structural engineering and civil engineers have come together, and they have formed an organization called London Energy Transformation Initiative, and they have published two booklets on this topic. This is one of the first thing, and they are following it. They are very seriously following it, and even the Carbon Leadership Forum in the United States is also supporting this. The structural engineering community, they have, I think this is one of the world renowned body of institution of structural engineers, because ultimately it is the design engineer is a structural engineer. So the structural engineer, they say that you have a responsibility to help mitigate carbon effects by changing the way buildings and infrastructure are designed, commissioned, and constructed. So this is they're appealing to their members that climate change and biodiversity emergency has already arrived, and it is you who have to do this. And they have agreed. They have agreed, and they have been doing this. In fact, I'm saying that many of this consulting engineers association and consulting engineers company, world renowned company, they have also planning and to achieve net zero in all their designs. So they have committed, they have come forward. Now, see, the next question is, how do we reduce the carbon from building and construction? So the first is, of course, the operational carbon. Now, operational carbon means the energy used in the building's life. It is energy centric. So suppose you say what is needed for the operation of a building or an infrastructure. So it is required, energy is required for heating, cooling, ventilation, lighting system, for which we use fossil fuel, mainly the coal. We have fridges, washing machine, TV, computer, etc. Everything in our offices and in our houses. Now, what is being said is that all this requirement of the energy for the operation of the building has to be taken care of by the renewable energy. And this is the important thing, that we have to reduce our dependence on the grid. The structure needs to be designed in such a way that slowly the structure, the buildings, infrastructure, etc., whatever is the energy requirement on a day-to-day basis has to be met with the help of the renewable energy. This is the first thing. Now, how do we do that? Now, this is our architectural people come into effect, come into force. Now, they have been doing this. In fact, there is a ECBC code, which you are all of you must be aware, that what the ECBC code is saying, they are insisting on passive design of building. So this is the passive design, that you have to consider the building orientation and envelope in the design itself. So the lighting and the the sound and many other requirement of the people staying in the building has to be met in a passive manner. The design of the building should be such that the the wind and the lighting has to be taken care of in the design of the building. Now you just think about whether your buildings are satisfying this requirement or not. Now henceforth you will have to emphasize on passive design necessarily. Now you also have to have the energy efficiency appliances in your building, so that will take care of that. And now whatever is after accounting for this, whatever is the energy requirement of the building, now you have to depend on the, the active thing, that is the renewable energy. So simple thing, when you design a building, you have to depend on the passive architecture, the energy efficiency appliances, and third is the renewable energy. And this is how we can do that with the help of photovoltaic panel on the panel or on the wind energy. So wind and photovoltaic jointly together we can make use of. Now the main question that comes to me is that India is a tropical country, and we are fortunate to have a large amount of solar energy, which is today not being tapped, which is just going west. So why can't we make efforts in tapping it to the maximum extent? Now you will find that how do I do this when yeah, there are multi-story buildings in my locality, for example, big cities, multi-story buildings. So now the government has come out with the concept of solar farms and windmills. Windmills have been there for a long time, but today you will be finding that Adani and Reliance. These are two big names which comes to my mind, that they have been setting up, or they are planning to set up very big farms, solar farms, and because ultimately we have to achieve 500 gigawatt of renewable energy. Now, in spite of using this 500 gigawatt, we will still be using coal because our requirements are very large. But 500 gigawatt, which means 500,000 megawatt of energy to be produced from the renewable sources, we can't just depend on rooftop solar. We have to have solar farms for this, and the government is serious at this. And what the World GBC is saying, that if you are not able to satisfy in uh, major cities high-rise building, you don't have the area requirement for setting up of the photovoltaic panel, then you have to depend at a national level. At a national level, your energy requirement of the total housing and infrastructure has to be met with renewable energy, and that is, you will be seeing that the government has been trying its best to, increase the share of renewable energy. Now, this is one very good example which has come to my notice. This is the first building which is the CII headquarters in Hyderabad, which has become totally, not connected to grid anymore. It is having its own energy requirements satisfied through the aspect which I have just been talking about. So, as far as the operational energy is concerned, this is the first building in India, and there are something like 25 such malls and big things which are now being made net zero operational energy projects today in India. So the moment has started in this direction. Now the problem is not this. The problem is our own sector. As you can see here, that this is where we are lacking. That when a huge amount of solar power is available to us, why can't our houses increasing the use of solar energy in our day-to-day use? The government has agreed 40 gigawatt, 40 1000 megawatt to be generated through the building, but see the actually very low kind of a here happening, and we are responsible for this. Now, the government is giving a lot of incentive to you, and there is a dual metering system which was started by the local electricity board. Yet people are not coming forward. People, wherever possible, we should try to tap the solar energy and the wind energy to the maximum extent. Now, coming to embodied energy. Now, first we have completed how to take care of the operational energy requirement of a building and reduce the operational carbon. Now, what about the embodied carbon? Embodied carbon is, I think, we have to go to this, the ISO, which is telling us the life cycle assessment. We have to now do the life cycle assessment of the building right in its design stage. Now it has been divided into five stages. One is the product stage, second is the constructions process, third is the use stage, and the fourth is the your end of life stage. We have to also consider what happens to the building after deconstruction and then beyond deconstruction. The entire carbon generated in this process by the product that we use here, sorry, by the product that we use during entire life cycle of this building, we have to calculate right in the beginning. And our job is made simple because of the fact that almost 50% of the embodied carbon is generated in the product stage. That is, in the production, raw material extraction, transportation of the raw material, and manufacturing. Almost 50%, whether whatever we use for our buildings today and in construction, 50% is generated in the process. Now, why not concentrate on this 50%? Now, coming to this 50%, you will also find that two things. One is this cement and steel. 7% is coming from cement and 8% coming from iron steel. So these are energy intensive processes which are used in the production. So it is the duty of cement and steel sectors to become uh, carbon neutral. But for that purpose, they have to depend on the new technology. Now, what are these technologies? Now, one study has been done and in the USA, and it says that now suppose you use a variety of materials in the construction: concrete, steel, insulation, glazing, and finishing material. He says that if you can optimize concrete mixes, then you can reduce almost 14 to 33% reduction in the happening in the carbon. The problem that comes, I think some of you might be involved. I'm directly involved in this area, and I see the waste of use of ordinary portable cement. Wasteful use. People don't believe, and people, the mentality is still there that use more cement in the structure, use more steel in the structure, and the structure will be safe. It is not like that. We have to optimize the concrete mixes and use it wherever it is. Similarly, you have to consider recycling as one of the major area of, because the raw material on the earth is finally limited. We can't generate the raw material. And what is happening today is that most of the we don't consider the way the industry is going. We are not preserving old building. We are just mercilessly bringing down the old building, and this is happening because the cost, because the owner of the building as well as the builder thinks that if he can construct a new tower in this area, a huge money he will get. Is it is it a good way of looking at the whole situation? So we need certainly a new construction. There is no doubt on that. But then all our activity of construction should be directed in such a way that uh, the carbon emission is reduced, whether it is old building or new building. Now, tools to achieve. These are given by Professor P.K. Mehta from Caltech University, United States. He has given very three simple tools to cement and concrete sector. Very simple. That he says if you have to sustainable in cement and concrete construction, use these three tools. One is consume less concrete for new structure. Interesting. You talk about this to the cement and concrete people, they will laugh at it. But yes, I say that we can design the structures in such a way. There are new technologies also available today that we can design and use material efficient design to use less amount of cement and concrete. Second is use consume less cement. Why we need to use large amount of cement? We can design the mixes in one of the most optimum manner and use clinker, which is the main material before cement is made. So consume less clinker in the construction. So this is what the roadmap of carbon neutrality given by the Cement Global Cement and Concrete Association. That this is what we need to do in cement and this is what we need to do in concrete. Similarly, all other construction materials have to come forward. Since I'm connected with cement and concrete, I know what's happening here. Now people are talking about interesting thing is here of course one area is this is a new technology and that your deployment of carbon capture, storage and utilization. This technology is going to be one of the major developmental area that you will see in the coming decade. That carbon is generated in the process of making cement or in the process of making steel. Now, why can't we capture this carbon, store this carbon, and utilize it to make carbon product, carbon-based product, building material, building components only? So this is the area, and some progress is already made in this area, and in the concrete field, reducing the content of cement using more efficient big designs, processing, and CO2 uptake through the circular economy. Now I have made some uh, work since I come from the ready-mix concrete industry. I just have took some mixes, concrete mixes, pure OPC mixes, fly ash mixes, and GGBS mixes. That is one using OPC plus fly ash, which is a waste product from thermal power plant, and another is ordinary Portland cement using blast furnace slag from the steel industry. And I tried to find out the global warming potential, that is the carbon emission from various mixes, and I have made certain assumptions for this. Of course, these assumptions are based on the data, and I have found that this is the picture that emerges, that for various grades of concrete that we use in building, right from M10, M15, M20, 25, 35, you will see that this is the the OPC, pure OPC mix, and this is the mix with fly ash, all these mixes. So the carbon emission is reduced, and if we use GGBS, it is used further. And what I have done is I have not gone beyond what the code has given. But the tendency today is that even now, many structural designers as well as many civil engineers, they say that it is only ordinary Portland cement concrete that is good because it gives strength. Strength is the only criteria. But I as the chairman of the committee on durability set up by the Indian Concrete Institute, we have published one handbook on durability of concrete. And we have shown that the larger the supplementary cementitious material that we use in concrete, the more durable the concrete becomes. And this is the fantastic thing, that we have to now use more and more supplementary cementitious material in the concrete so that the ordinary Portland cement is used on a low scale, so carbon emission is lower, and we are able to save the limestone for the future generation. Now, high strength concrete. Why can't we increase the use of high strength concrete? Now, I have certain things because we are now. I am involved since I give this example because I am involved in this. Now we use in tall building in Mumbai and many other metropolitan cities, we use high strength concrete. Now why we use high strength concrete? The simple thing is that if we use, instead of say M40 in a building for beams and columns and slabs, I just change it from 40 to 85. I just, because today we are capable of designing concrete of M80, M90, M100, even 100 is also designed. So what happens is we can reduce the section sizes if we are, using high strength concrete, high performance concrete, and simultaneously we are also able to reduce the reinforcing steel requirement. So, and what is more important is that the increase in the floor space, which is very important. Now, you take the example of, say, Navi Mumbai area, where the land rate is something like maybe around 10,000 rupees per square foot in some areas. If you go to Mumbai, it will be 25,000 rupees per square foot. So, any area that you save because of the use of high strength concrete is a valuable thing, because you can increase the floor space by using less concrete and less steel. And this is what is happening, that these are the some of the other advantages of using high strength high performance concrete. You get higher column free spaces, aesthetically pleasing. High early strength also can help you in expediting your construction. and then construction cycle can be reduced. There is a heat of aggression, which is harmful for concrete, can also be reduced. Long-term durability can be improved, and you get a service life of 100 plus years. So use less material. So our objective of reducing carbon footprints is, you know, solved. This is not my data. This is the data from taken from UK, and which shows that even grades of M70 and M80 concrete, you can reduce the carbon emission. Now, one area where I feel that the code also has to change, and one is that our concrete is designed only for 28 days strength. Every contractor, every builder, every consultant will see that concrete if it is satisfying the 28 days strength requirement. Now, my submission is that why can't we increase this 28 days to 56 days? Now, the whole idea behind is that we can save a lot of material uh, and a lot of concrete, lot of ordinary Portland cement through this. I will come to this other aspect, but this is where I have made the study that you take M35 concrete for foundation. We use for foundation. Now the load on the foundation will not come immediately because the building has to get constructed. So it will take 3 months, 6 months, or even an year for the building to get the full load. So why not take the chance to design the foundation for 56 days? So this is one example that IS 456 requirement for M35 is 380 kg of cement and water binder ratio 0.8045. Now I have changed this mix and I have adopted instead of 340 kg OPC I used 130 OPC. Sorry, I used 130 OPC and I replaced it by 190 kg of GGBS, keeping the water binder ratio same. And you see what strength I got. This is large number of data which I got from this is the 28 days strength, this is the 56 days strength, and this is the 90 days strength. So, which means that because of the use of GGBS, we are increasing the compressive strength achieved in actual practice. So, my submission is very simple that for foundation of M35 grade concrete, we must use using 56 days strength. So once I use this because I achieved the required strength of 35 MPa, but I achieved it instead of 28 days, I achieved it at 56 days because which is not needed for that structure. So why not we change this requirement and make it 56 days so we can in the process save something like from 340 kg cement we can reduce it to 130 kg cement. So 1 kg of cement is almost equivalent to zero point 0.8 kg emission into the atmosphere. So we can reduce, if we can reduce, say, by something like 200 kg of cement per cubic meter. So 200 means almost 160 kg of emission we can reduce by this simple change in the method. Now there are chances of making uh, making conversion into the structural system also. For example, instead of your frame building, especially I've taken this thing from the Concrete Society UK, we adopt this various methods of construction Instead of normal construction using column beam and slab construction, we can adopt variety of options for the structural engineer, and this is what the structural engineer has said that if we can mid-size frame building, and this is Arup is one of the big consultant worldwide, and this is their own experience. That the research done by Arup has said that the structural engineer can play an important role in reducing buildings' embodied CO2 by as much as 100 kg of CO2 per meter square. And this is their own experience. This is not a small reduction. So, design and material specification has the potential to save almost 1,000 tons of CO2 in a building. So, similar research is essential in our country also. How much reduction we can do by just changing the form of the the design. I'll just give you some example here. For example, if you use hollow core slab instead of solid slab, now this hollow core slab is available now. Most of the precast manufacturers they use it because it is self weight is lower. Then acoustic insulation will happen, and because there is less of material here and a lot of air is inside, so thermal properties will improve. Heavyweight capacity instead of having reduced concrete content. We can construct very rapidly, higher fire resistance and very cost effective. And most important is that it has reduced carbon footprint. So by in the design itself, if you can change instead of making use of solid slab, one-way slab or two-way slab, we can use these panels in the buildings, especially in high-rise building. We can make use of this. Use this hollow system to pass on the services. So that will also not be seen. It can go through this, and then you also end up in reducing the weight of the building. So reducing the foundation cost also helps in the thermal property, insulation, and other things. You can also use voided slab. Now, this is very simple that we can use save material up to 30%, and we can also save steel also up to 10%. So these are some of the interesting structural way by which you can make reduction in the material use and waste reduction. Now, I just give you this below one my personal experience where I was involved in a supplying concrete for project, and the structural engineer says that after construction, it has come to his notice that he has to make use of the certain open cantilever portion of a building. Now, the main problem was that the structural weight need to be reduced on the building on the slab, and then so you have to use low density concrete for this purpose, and also see that how we can reduce. So here what he has used very innovative. So we have instead of using this you know PVC material, we have used here ceramic pots, matka. So we have just reversed the matka here and then tied it with reinforcement and then poured the lightweight concrete. So this is the innovation that with and innovation, you can certainly use and reduce the carbon footprint also. The waffle slab is another area where a very aesthetically pleasing design can be made, but again, you can reduce the amount of concrete into the material and so reduce the footprint. Now, one very interesting thing has come for ground plus three or ground plus five building construction, that is a sandwich panel. The variety of technologies are today available, but this is one technology which has I have seen myself and which has appealed to me. It is nothing but a ferrocement type construction, but using a thermocol inside. So this is the thermocol, or what we call as EPS, expanded polystyrene sheet. Maybe it is around 100 mm or 50 mm thick. On one side, you have the reinforcement cage tied to it, and now these panels are made in a factory and they are made available to you. And on site, you can just uh, put the panel in place and then put the shotcrete, about 30 mm shotcrete on both sides. So this is expounded polystyrene slab which has been made, and these are the some of the panels which has been used in the construction of a normal ground plus three-story building. Now, why can't we use it? Especially this building is very light and can be done by mason, because the panel I have also I was person like me was able to lift one panel and place it in position. Now, one interesting thing in this area that has happened is that IIT Roorkee has published one paper saying that the seismic design of this panel is excellent, and this is by their modeling method they have designed it and published it. So even in an area which is prone to disaster, earthquake disaster, you can construct a low cost building, ground plus three story, and which is of course less material use. Not only that, you are using a waste material in construction, that is polystyrene, expanded polystyrene, that is thermocol is a is a waste material, and not only that, it is harmful. Disposal is very difficult. But if you use it in building in a nice way, it can improve your thermal insulation on the one hand, and on the second hand, it is cost effective, and large number of building can be constructed with this. Now, before I almost I coming to the end of this presentation, but the point that I'm trying to make is even in our day-to-day life, we can reduce carbon. This is what suppose you become environmental friendly or environmentally conscious person, then if everybody does it, then you can also have an impact on the environment. So why not change our lifestyle? Now, for example, one of this uh, estimate has been given that you reduce your air travel, because air travel uses a lot of energy. So you reduce your air travel and you reduce save 1,000 kg of carbon equivalent. Secondly, you reduce your non-vegetarian and beer in your diet, and you reduce 2,000 kg CO2. Of course, this is not applicable to us because we don't eat that much of meat. in our daily life. Uh, this is basically for the people from Europe and America who consume a lot of meat in their day-to-day, you know, lunches and dinner. You can stop driving the car and use public transport, so you can save almost 3,000 kg CO2. And third is, and last, I think the one is that if you are a structural engineer or if you are an environmental conscious engineer, you can save uh, 20% of the structural embodied carbon from the construction, and thereby save almost 200,000 carbon emission per year. This is guidance given by the Institution of Structural Engineers to its people. So we can make a difference. We as an engineer can make a difference, and I'm especially accepted this invitation because I'm speaking to teachers. Now, these teachers will ultimately speak this thing to their students. It is important because the student had to get acquainted with this thing. We are not going to, at least, I am not going to stay till 2070. Some of you might be, but the situation will be serious at that time. So, in order to avoid that, why not start using this? And this has to be emphasized uh, to the student community, and you are the most important factor in this communication. So, I would request you to pass on this message to student. If you want my help, I will always be ready to talk to your students. In fact, I would love to do that to your student. So conclusions that climate change has arrived, and it's a stark reality. We have seen in this the bad effect. India is prone to devastating effects of climate change. We have already seen that, and more things will happen now. Uh, India's commitment to achieve net zero carbon by 2070, this has been agreed by our nation to the world community. So we have to start preparing for it right now. Building and construction sector account for 40% of the carbon emission, and that is why we have a responsibility towards the society as a whole, uh, uh, towards the whole humanity as a whole, that we can reduce the adverse effect of climate change. We have to have constructive, resilient structures which which can withstand the adverse effect of climate change, and at the same time we can reduce the carbon emission through our own day-to-day construction. Decarbonizing these sectors is a cost-effective way to mitigate the adverse effect. So, one of the most simple method of reducing carbon emission. Operational carbon and the embodied carbon, we have seen whatever is the difference between that, and it is the our responsibility to see that we are using more and more of renewable energy to reduce the need of operational energy in the building. Use the wind and the sun to our advantage, and then use materials. You have to have the material efficient design in construction. I just given you one example of cement and concrete, but other material like steel, like the the facade, and the material used for your other activity, plastering, finishing, your other material used for plumbing and other fixtures, etc., etc. All have embodied carbon, and we have to ensure that all this material we use and suggest they are having lowest embodied carbon. So material efficient design has a very important. So we have to unite to fight this thing. Now, little bit about my own effort in this. So I have started this to a low carbon construct forum, a non-profit organization, and the whole objective of this forum is to create awareness about carbon emission and how our engineering fraternity can help in the reduction process. And this I have started publishing quarterly on this topic. I have already published three such issues, and these are in front of you. This is my website, and this is the newsletter which is published. I'll be happy to share your these issues with you, provided your professor permits me to have your email so that I can send you the soft copy of this newsletters on a regular basis without any cost to you. This is the second newsletter, and the third is of the launch. So I am finishing my lecture in 1.5 hours as demanded by your people. So now I think I'm opening this forum for any questions and answers.
Thank you so much, sir.
Welcome.
Sir, I personally like the concept of high strength concrete and steel that save the space and save the steel.
Hmm.
Very interesting concept that. um, Actually, I got too much appreciation messages on YouTube live chat. Many participants like the sessions. One participant's Moiresh Naikwad's message that nice sessions are very knowledgeable and great example of real life scenario.
Hmm.
And many participants send the message like uh, your explanation made it easy to understand this topic, like that. And we
Hmm.
have some questions also, sir. So shall we go for the question answer
Yeah,
session?
yeah, certainly, certainly.
Okay, okay, sir. Sir, um, first question is from the Manas Parab.
Hmm.
Is there any effect of curing period when we compare the OPC and OPC plus GGBS on the strength of concrete?
Yes, I think very right question. I would say that curing period is increased as per the Indian standard specification IS 456. We require larger curing period for the concrete that is using the supplementary cementitious material, because ultimately what's happening in this supplementary cementitious material is that the reaction happens at a later stage. In OPC, when we use pure OPC, the strength is achieved because of the immediate reaction. But when we use either fly ash or GGBS into concrete, the reaction happens slowly and with a view to permit more of this reaction to happen. Uh, the curing period is increased. But interesting. I know the where the person is trying to pinpoint certain thing that we require more water for the curing. Is this the question? For that, I have also the answer that a lot of research is being done today lot of research, and we are now witnessing the rise of, you know, a concrete which does not need curing. Slowly, the technology is changing, and we can use certain ingredients into the concrete by which you don't need to cure the concrete. you don't you don't need the water to cure the concrete, but such technologies come, they take a lot of time to come. But the scientists and the engineers, they are already developed this technology, and what today we are using, they are already available at the commercial level. Because when we develop something in the lab and in the academics, but to go to that technology to commercial level, it takes a lot of time, because the commercial angle is a different angle, and people always compare the cost, and there the problem comes. So by the time the technology becomes cost effective, people wait for that period. Till that time, yes, we require more time for curing. But let us wait and see the rise of self-curing concrete, which is on the horizon now. Thank you.
Thank you. Thank you so much, sir. So, second question is from the Jyoti Shinde ma'am.
Hmm.
Sir, is there any specific or standard bylaws or rules for reducing the carbon under state or central government?
Yes, I think Jyoti,
Mm.
I must congratulate you because you have hit the point. In fact, you have highlighted the need. And I must say that this is one area where we have to work. That there has to be a law of green procurement, and many countries have started doing it. In fact, I know in United States there are at least 50, out of the 50% of the states, they have the laws enacted to procure any material. You need a legal sanction, and the legal sanction says that now suppose you have to procure an ordinary Portland cement. The state has given you a code by which you say that there is IS 269, which the cement has to conform to that IS 269, and you are satisfied with that. But now the new requirement is that for the climate change area is that the cement also has to satisfy the carbon emission requirement, which means that the state has to say that this material you need to use a material which has this much of carbon content, and the competition between the different players has to happen based on how much carbon reduction one particular brand of cement can give you compared to the other. So this is very relevant question. In fact, no progress is done today in our country, and an urgent need is there to legislate state laws as well as central laws on the requirement for the procurement of material. Yes,
Thank
thank
you.
you.
Thank you so much, sir. Sir, next question is coming from the Dattatreya Bangar, sir.
Mhm.
Sir, can we use the voided slabs type currently in large scale in Maharashtra?
Why not? Why not? We can use as long as your structural engineer is able to design it. One area which is needed for voided slab is a self-compacting concrete, because the concrete has to travel through the thin area between the voids what we have made. So that is, once you have a self-compacting, self-leveling concrete, you can construct a voided slab. There is no issue.
Okay. Thank you
Hmm.
so much, sir. Here our question answer session is end up. And
Mm-hmm.
thank you, sir, for sharing your
Now, madam,
valuable
I have one
knowledge.
request to you
Yes, 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 sir.
that
Definitely.
if you can kindly share the email IDs with me
Yes,
of the
yes,
participant, I will
yes,
send free of cost copies of my newsletter,
yes.
and this will
Definitely,
come to
sir.
them other
Yes, sir, definitely, sir. Because
regularly to
participant also
them.
interested in that.
So regularly, I will send it to them, and they can pass it on to
Huh.
their students.
Okay.
So
Yes, yes,
ultimately,
sure,
the
sir.
main objective is student.
Right, right.
Because
Yes.
we are already advanced in our age. We may not see the effect of bad effects of climate change, but the future generation will see.
Right.
So you have to make them aware of it. So it is our
Yes.
duty. Actually, it is our duty.
Yes.
So I'm happy to be with you today and share these things so that
Okay.
you
Definitely, sir. We can proceed these things as many to as many people, teachers, faculty members, and industrialized also.
welcome, most welcome.
Thank you, sir.
Thank you very much. Thank you.
Okay, sir.
Okay, thank
So
you.
now, participant, I have end up here the session one of the fourth day of the STTP. Feedback form will be provided on the WhatsApp group, and for join second session of the fourth day of STTP at 1:30 p.m. So join us sharp at 1:30 p.m. Thank you so much.
Thank you very much.